Error due to coefficient A is removed by turning the compass to realign the lubber line with the fore and aft axis of the aircraft. Let's say the error is +2 degrees. Error due to coefficients B and C are removed or minimized by creating local magnetic fields with additional magnets which are equal and opposite to the aircraft's magnetic field. Coefficient B is removed on headings of east and west. Let's say the error is +4 degrees. And coefficient C is removed on headings north and south, because as we saw from the graphs earlier, the relevant coefficients will be at their maximum on those headings. Let's make the error due to coefficient C -2 degrees. However, it is unlikely that all the deviation will be removed by this process, and therefore any residual deviation will be recorded on a compass deviation card, which will be placed adjacent to the aircraft compass. We can see a typical example here, and we can see that the compass is indicating 270 degrees or west. The compass heading is the magnetic heading plus or minus the deviation on that particular heading. So the deviation card is telling us that to fly an accurate heading of 270 degrees magnetic or west, we should steer a compass heading of 269 degrees. In accordance with EU OBS, residual deviation limits are as follows. For the direct reading magnetic compass, it is plus or minus 10 degrees. And for the remote reading magnetic compass, it is plus or minus 1 degree. Aircraft magnetism is influenced by the Earth's magnetic latitude and will actually change as magnetic latitude changes. Let's see why this is by looking at the effects of the Earth's magnetic field on hard iron and soft iron as latitude changes. Earlier, we saw that hard iron magnetism can be regarded as permanent magnetism and is not affected by external fields. So if aircraft magnetism due to hard iron does not change, what is it that causes deviation to change as latitude changes? The answer lies in the relative strengths of the Earth's Z and H components. We know from the lesson which dealt with magnetic dip that the Z component of the Earth's magnetic field will be at its weakest at the Earth's magnetic equator and strongest at the magnetic poles. Conversely, the horizontal component of the Earth's magnetic field, which we call the H component, reduces as the Z component increases. In other words, the H component will be at its strongest at the Earth's magnetic equator and at its weakest at the magnetic poles. Let's look at the effect this will have on deviation. We know that aircraft magnetism due to hard iron can be assumed to be constant, and we can represent this constant by the blue line here. As the directional strength of a compass needle is governed by the strength of the Earth's H component, represented here in red, we can see that deviation will be low near the equator, but will increase towards the pole as the effect of the H component decreases. We can say therefore that with hard iron, aircraft magnetism does not change with magnetic latitude, but deviation will change with magnetic latitude. Let's look at soft iron now. We know that in soft iron, magnetism will be induced when there is an external magnetic force present. This includes the Earth's magnetic field, and in particular, the effect of the vertical, or Z component of the Earth's magnetic field on the aircraft magnetism. As we know, the Z component will decrease and the H component will increase towards the magnetic equator. We can see therefore that deviation due to soft iron will be greater as magnetic latitude increases, Firstly, because the strength of the Z component increases, and therefore the aircraft magnetism increases. And secondly, because the horizontal influence of the Earth's magnetic field decreases, other external influences will have a greater deviating effect. We can say, therefore, that with soft iron, aircraft magnetism changes with magnetic latitude, and deviation changes with magnetic latitude. There are a number of occasions when a compass swing will become necessary. They should be noted, and they are: 1. When the compass components are installed or replaced. 2. Whenever accuracy of the compass is in doubt. 3. After a maintenance inspection if required. 4. After significant aircraft modification, repair, or replacement involving magnetic material. 5. When carrying unusual ferromagnetic payloads. 6. When the compass has been subjected to significant shock. 7. After the aircraft has been given a new location to operate in, if the move involves a large change of magnetic latitude. 8. If the aircraft has been parked in long-term storage on a single heading. 9. In the event of a lightning strike. 10. After significant modification to aircraft radio and electrical systems. This concludes the lesson on aircraft magnetism. A summary of the main points follows. A summary of the main points of the lesson is: deviation is classed as easterly or westerly, depending on whether the compass needle lies to the east or west of the magnetic north meridian. The resulting direction in which the magnetic compass points is known as compass north. The aims of the compass swing are A. To observe and determine the deviations between magnetic north and compass north on a series of headings. B. To correct and remove as much deviation as possible. And C. To record the residual deviation which is left after the compass has been adjusted. The contribution to deviation from longitudinal aircraft magnetism is a function of the sign of the heading. The contribution to deviation from lateral aircraft magnetism is a function of the cosine of the heading. Deviation on any heading equals coefficient A plus coefficient B sine heading plus coefficient C cosine heading. Coefficient A is the contribution made to the total deviation should the aircraft compass be physically misaligned with the longitudinal axis of the aircraft. Coefficient B is the combined longitudinal hard and soft iron component of aircraft magnetism. Coefficient C is the combined lateral hard and soft iron component of aircraft magnetism. The regulatory residual deviation limits are plus or minus 10 degrees for a direct reading compass and plus or minus 1 degree for a remote reading compass. Hard iron aircraft magnetism does not change with magnetic latitude, but deviation does change. Soft iron aircraft magnetism changes with magnetic latitude, and deviation changes with magnetic latitude. The occasions when a compass swing may be necessary should be noted.